Hi friends, welcome to this class. In this class I am going to discuss about these enantiomers. As I have told this enantiomer, see here, let me take example. Here methyl group, here COOH, let me write here COH, here methyl, here hydrogen and here OH. If I ask you to give the configuration, you will give because 1, 2, 3, 1, 2, 3. Since it is anti-clockwise, hydrogen is above the plane, so this will be R. And if I place a mirror here, I will get, if I place a mirror, only these positions are interchanged. I told one time interchanging, we will get its enantiomer methyl. So it will be, yes, no doubt, you can name it. I should not write OH like this, I should write OH. It means O is attached to this carbon, right? Yes. So I told these two are enantiomers. So I also told the definition. Enantiomers are the compounds which are optically active. They are having chiral carbon. They are optically active. They are mirror image of each other. And one more thing I didn't tell you, that these are non-superimposable. If I, see, this is my hand. Let me take the example of this hand. Right? This is hand. This is also hand. If I place this hand in front of mirror, I will get its mirror image like this. If I try to superimpose, see here, these are not superimposing, right? Superimposing means this thumb should be overlapped by thumb, all fingers should be overlapped by their own respective, but this is not happening. So these are enantiomers. These are non-superimposable. On this also I have made video on optical isomerism, molecular modeling, using which I have shown why chiral carbon, if this carbon attached to 4 different atoms is chiral, why not if same 2 groups are attached to the same carbon. I also told, and also I have told, if same 2 atoms are attached, you can cut into 2 equal halves. See here, I have given you one reason, that is here, if same atoms are attached, methyl be here, COH be here, H. Let us see this. This is not chiral. Why? Because same 2 hydrogens are attached to a single carbon. So it is not a chiral. And also I can cut this plane like this. See here, if I cut, this methyl will be equally halved, this OH will be equally halved, and this is mirror image of this. So plane of symmetry exists. So such compounds are optically inactive. I told this one reason, and also one more reason is, if I place a mirror here, I will get COH here, methyl group here, and H here, and I can rotate this by 180 degree within the plane. I will get the same molecule. So these are superimposable. I can rotate and I can impose on it. Impose means I can overlap and both the molecule will be same. So it is having superimposable mirror images. Whereas this one, you do whatever you do, you can't superimpose. If I rotate also, and if I try to place, this methyl goes up and it can't cover this COH, whereas COH comes below here, so we can't superimpose. So enantiomers are what? Enantiomers are having chiral carbon. These are optically active and it has got its mirror image, and mirror image is non-superimposable. This is about enantiomer, right? So we discussed about enantiomers. Let us see what are the similarities and differences in enantiomers. Let us see this. See here, enantiomer. This is R enantiomer and this is R and this is S, and both are enantiomer. Both are enantiomers, right? See here, this both R and S. Let me name them by R and S. No problem. This R and S will react same with the achiral compounds like OH minus. OH minus is a achiral base. It will react, the rate of reaction of this R and the rate of reaction of this S will be same. So K of R, its name I called it as R. K is what? Rate constant, and rate constant of S will be same because both will react same with this base OH minus. So the reaction with a chiral compound will be same. First point has been discussed. Both this R and S will have same melting point and boiling point. And also I have discussed about racemic mixture. What is racemic mixture? If I take this 50% R and 50% S in a beaker, then the solution is racemic mixture, I called it, because it is not going to rotate any plane of flow rate in any direction. Why it is not rotating? Because 50% of this and 50% of this is combined, so it intercancellation occurs, so it is not going to rotate plane polarized, right? That is racemic mixture. See here, if in a reaction, however, I was doing reaction and I got this racemic mixture, 50% of this and 50% of this, and I want to separate them. I want to separate this R and I want to separate this S. How should I separate? They are having same melting point and boiling point. If I keep it for vaporizing, both are having same melting point and also same boiling point, so I can't separate. And also it has been told that both are having same retention factor, RF. In RF, retention factor means it is a distance from paper chromatography they will learn about this retention factor. If I do videos, you will get to know retention factor. Both are having same retention factor. If they are having same retention factor, then also we can't separate. In column chromatography we can't separate. Using paper chromatography also we can't separate. If they have different retention factor, we can easily separate. But both R and S are having same retention factor. That's the demerit. So we can't separate easily. So they will react same with achiral compounds. They will have same melting point and boiling point. They have same retention factor and also same solubility, because both are having same molecular formula. Here also H, here also H, here COH, COH. If I put in water, same hydrogen bonding, everything will be same. So their solubility will also be same, right? And same crystallization. If I keep for crystallization, since everything is same, this will also be same. But few things are different. The different things are written here. See here. See here. This is R and this is S. One may act as drug and other may not act as drug. That is, one may be good, one may be bad. It may act as drug, it may act as poison, or it may be useful for us. But if it acts as drug, it will be useful for us. If it is acting as poison, it is not useful. So one difference is it may act as drug or it may not act. And the other difference is both R and S are non-superimposable. That I have discussed. And also see here, if I passed, this also I have discussed. If I passed a plane of plane polarized, right? What is plane of plane polarized, right? That also I have discussed, right? If I pass a plane of plane polarized, right? Let me call it by name R, right? I have called it by name R. One will rotate, let me say this R will rotate the plane of plane polarized by light by left side, whereas S will rotate the plane of plane polarized by right side. So one will rotate in anti-clockwise left side, one will rotate in clockwise, that is right side. So they differ in interaction with plane of plane polarized, right? They are non-superimposable. These are the differences. One may act as drug, other may act as poison, or one may act as drug, other may remain as it is, right? And this fourth one is reactivity with enzyme. See, enzymes are very specific. They may react only with this S, they may not react with R. So reaction with enzyme differs, right? And other thing is, and also with chiral compounds. Here I put achiral compounds like OH minus. Sometimes what happens with chiral carbons, one may react, let us say this R reacts, but S may not react. So with chiral carbon, this react, so it has got Kr. Since it is not reacting, Ks will be 0. Where K means rate constant of S will be 0, whereas rate constant of R will be somewhat, because it is reacting with chiral carbon. Similarly, I told with enzyme. This is enzyme can react because enzymes are specific, so only they react with S, they may not react with R. So these are the few differences and similarities for this enantiomers. Most of the things I have explained, but little bit here and there it may happen, but if you go like series of videos you are watching, you will get to know everything, right? See you then. Next class we shall discuss about diastereomers. Till then, take care.